this edition of SPSS tutorials, we are going to be talking about how to compute a t-test using SPSS. So I've got my SPSS data open here. I'm using the General Social Survey 2008. Now, in order to do a t-test, I need two variables. I need one variable that has two categories, as a yes, no, or something of that nature, and then I need one variable that is numeric. So I'm going to use the variable hours worked and sex. So I'm going to look at men and women and who works more hours. So I am going to go to Analyze. I'm going to go to Compare Means, and I'm going to do an Independent Samples t-test. So I'm going to click on Independent Samples t-test. I'm going to put my variables in. So I have a test variable and a grouping variable. So my test variable is the variable that's numeric. And so I'm going to put my hours worked in there. So again, this is my numeric variable. It's the one that I can calculate a mean for. And then I'm going to put respondent sex as my grouping variable because I want to divide my data into men and women and then compare their responses. So now there's one thing I have to do before I can click OK. You'll notice I can't click on it. So I need to define my groups. And so I need to determine, I need to tell it what the coding is. So my groups are group 1 and group 2. And the reason why is because in my coding of male and female, so if I go back into the data, you'll see sex. And if I open this up, you'll see that 1 is coded as male and 2 is coded as female. So in the value labels here, when I opened that, it tells me how that's coded. And so I want that to be how I define my groups. Sometimes you'll have a 0-1 variable, and so you just need to decide how you're going to divide that. So once you have determined that, you don't need to do anything else. I'm going to click OK. And here is my output for my t-test. So it's kind of a bigger table. This first table just gives me some statistics. So I have 251 male respondents. I have 273 female respondents. And then you can see the mean for the hours worked. For men, it's 45.8 hours per week. For women, it's 38.83. So already just looking at this, it looks like men work more hours than women. But I want to know, is that a fluke or is that likely to have occurred in reality? And is that difference due to a real difference? So there are a couple of tests in this second table that you'll see. And so you see an F and significance and then a T. This is the one that we want to look at because we're doing a t-test. So I want to look at my T here. So I have a T of 6.177. You'll notice there are two values, and you can see equal variance is assumed, equal variance is not assumed. And so we're going to assume equal variances. It doesn't make a difference in this case, but you have your T, you have your degrees of freedom, which is 522, and then you have your significance. So this is basically telling you at what level is this significant. So you want this number here, which is now 0.000, you want that to be below 0.05. That's what you want. If this number is below 0.05, then that is telling you that this number, the T, is higher than the critical value at 0.05. And so this is actually telling you that this number, 6.177, is higher than the critical value for all significance levels with this many degrees of freedom. So again, what you're looking at is the T, the degrees of freedom, and then whether or not it is statistically significant. And here it is statistically significant. It is below 0.05, and that is good. All right, so that's how you would calculate a t-test. All the rest of this stuff on here has meaning, but it's not something that we are going to use. So we want to focus on just these 3 columns here. And that is our t-test.